Hi, I'm Shirls and welcome back to Edubof, where you will find tips for teachers and help for your students. In this particular episode of Edubof, we are giving help for our students, in particular my biology students, who are going to be completing their very first student experiment for QCAA. It is their first internal assessment. And I'm so excited because I know that they are ready for this. As you can see, Suse is still not with me. She's still in New Zealand. I believe she's having a lovely time skiing. You will find us on all the socials. I'm not going to list them. I believe that they're down below. You can have a look there. Check us out on the socials. Please subscribe if you enjoy this channel and click the little bell, which is also down below, so that you can get notifications when new videos come up. Down to business. I'm assuming that if you are one of the students completing a student experiment for their IA in biology or marine science, you will have a really good, thorough understanding of each of the pracs that you have completed in class. If you haven't, please go back and watch the previous episode, which is Starting Right Part 1 or Part A, and just make sure that you really understand each of your pracs before you make a decision about which prac you would like to modify for the student experiment. Your next step, once you have a good understanding, is to choose a particular experiment that you will modify and to make a decision about how you are going to modify it. That is really important, and when you are doing this, this is the time to decide how you are going to handle your data, what type of data you need to collect, how you are going to record it, and how you are going to process it, so that you can see whether there is any statistical significance to your results. So don't wait until you've collected the data, because by the time you've got the data, it's too late to do a rerun and collect it again if you have not collected the right type of data. Now, a little while ago, I came up with a data decision tree or a decision key that I devised for my students. I want to help to keep this completely simple. We need to focus on a few things, and statistics does not need to be one of them. So let's get right into this little data key, the very famous Shirley Carson data key. You're going to collect one of two types of data. We're talking here about your independent variable and your dependent variable, so you need to look at both of those. You're going to collect either discrete data or continuous data, and that's your first decision. So you need to determine whether the data you're collecting is continuous or whether it's discrete. Now, some of my students have got confused in the past because they say one of the data items is discrete and the other is continuous. Doesn't matter. If one of them is discrete, it goes under this side of the data key. If they are both continuous, you're going to go down this side of the data key. Now, it doesn't matter which you're collecting. The first data that you collect is raw data. We call it raw data because it has not been processed in any way. And the very easiest way to handle your data is to design your Excel spreadsheets ahead of time and put your raw data straight into Excel, whichever side of the key you're going down. Now, your data is going to determine how you set up your tables in Excel, and I will do a little short piece at the end of this key explanation to show you how to set up your Excel tables. Because if you get this right, then processing your data becomes super easy. And you want to focus on the biology. You don't want to be worrying about Excel. Excel must just do its job. Okay, let's say you have got continuous data, your independent variable is continuous and your dependent variable is continuous. Then don't even think about anything except a scatter plot. One of the most common mistakes that comes with scatter plots is that students do a scatter plot of the means. If you are plotting the means, it's not a scatter plot. A scatter plot is a plot of every single data item. So you're going to be drawing something that has got a fair number of plots on it. Scatter plot. That's all the data, not just the means. I know it sounds corny, but it helps me to remember that if I've got continuous data, I need to be mean to the means and leave them out. Just exclude them. Once you've got your scatter plot in, you're going to generate a regression line. The regression line is a fancy term for a line of best fit. Excel can do that. Excel can generate your scatter plot straight from your raw data. But when you generate your regression line, you need to remember that Excel doesn't have a brain. You need to be the brain. You need to think about what type of line you might be getting from the data. It might be a straight line, but for instance, if you were looking at the effect of pH on enzyme activity, you're more likely to get a scatter plot that has more of a parabola shape, in which case you need to make sure you use the correct line. In a later video, I will go into detail about that using the Excel data tool pack, and I strongly advise you to have a look at those before you finalize your data. Now we've got a trend line which we need to be able to interpret, but we also need to be able to use statistics to determine whether our data is statistically significant. And if you've got continuous data and you've done a scatter plot, then I strongly recommend an R-squared value, also generated by Excel. Interpreting the R-squared value can be a little tricky, but not too tricky. And again, I will be doing a video on using Excel and interpreting those numbers a little bit later. Now let's move over to if we've got discrete or discrete and continuous data. We've still got raw data, we're still putting it straight into Excel. Now it's a little bit different because here you are going to generate a mean. If you have set up your data collection tables correctly, all you need to do is press a button and Excel will generate the mean for you. And you are going to do a column graph. So remember that a column graph looks something like that, spaces in between, and you need to stick to just the plain columns, no fancy 3D shapes or anything like that. Column graph, that shape. Again, there will be another video later. Now, there are a few more choices on this side, because in the range of pracs that you have been given for your student experiment, you might be wanting to compare two sites, for instance, ecologically, maybe looking at Simpson's Diversity Index to see if there are significant differences between two sites that are spatially separated. If you are comparing two things that have equal size, you want to be heading towards a Ttest. So let's go down that little route first. Comparing two. Only if you're comparing two and we want equal size. So the same number of repetitions and the same scope. Now, we need to have another divide under that, because you need to determine whether the two things that you're comparing are independent of each other. In other words, they have no effect on each other at all, or whether the one is dependent on the other. Okay, if they are independent, that's an N. Independent, you are going to do an unpaired T-test, and you are going to generate a p-value. Again, you don't need to know the maths, you just need to know how to press the buttons on Excel. So easy, super easy. And if they are dependent on each other, then you are going to do a paired t-test. And you're still going to generate a p-value. Those p-values are used to determine whether there is a significant difference between the two things that you are comparing. Okay, lucky last. If you are not comparing, you're not comparing, or maybe you're comparing three things, or you're looking for a trend or a relationship, and you've got discrete data, you are going to generate the standard error. Please don't use standard deviation, don't use the range, just use the standard error. You don't need to know how to do it. Excel will do it for you. You just need to know how to interpret it. Once you've generated the standard error, you need to ask Excel to put the error bars, standard error bars, onto your graph. They will look something like that. And from those error bars on your graph, you will be able to determine whether there is a statistical significance to your results. And that's it. That's it. You don't have to make any other decisions. Make those decisions before you plan your method. Check them with your teacher, because this is going to ensure that you are heading completely in the right direction, and you will have far less pressure and stress when you are trying to complete your write-up at the end of the experiment. Setting up those Excel spreadsheets is important, the way you do it, the way you set it up. So let's start with, if you are aiming to do a scatter plot, because you have got continuous data in your IV and continuous data in your DV. You want to list the independent variable on the left. It doesn't have to be right up against the margin, so it doesn't have to be in column A. It can be anywhere on the page. I usually put it round about column B or C and a couple of rows down. But your independent variable needs to be on the left. You want to have, in the first cell, you want to have the heading and the units. So for instance, temperature, degrees centigrade. Now remember, you're going to have more than one repeat of each set of conditions. So if, for instance, we are testing the photosynthesis by algal walls at different temperatures, and we're going to have maybe 5 different repeats at 5 different temperatures, you need to write 25, 25, 25, 25, 25, 1, 2, 3, 4, 5. Those are your 5 repeats. It's a little bit laborious, but it's going to save you a lot of time later. Another thing to remember, Excel, when it generates statistics, cannot read degrees, it cannot read centigrade, it can't read letters. So in the cells themselves, where you're recording your data, you must have only numbers. So I've got my 5 at 25, my next 5 are going to be 30, 30, etc., all the way down. So you get a really long column. It doesn't look so pretty, but it works really well. Your dependent variable should go to the right of it. It doesn't have to be directly to the right of it, but it should be to the right of it. And remember again that you need to put all the information on your spreadsheet so that you're going to remember exactly what you've got there, because otherwise you're just going to have blocks and blocks of numbers. So we're looking at the pH here, because we're looking at the rate of photosynthesis determined by the pH. So maybe we've got 7.5, 7.6, 7.5, 8.2, and 7.7. Now right from the get-go, just glancing down your data, because this is where you first analyze your data, you can see this number's a little bit high. Don't write anything in there, but you might want to highlight that block just to remind you to come back to that one, because there might be some reason, something that might have gone wrong. You might have particularly virulent algae in that one, but that data item looks a lot different to those. So highlight if you like, but don't write anything else in those blocks. If you set it up like that, Excel will be able to do everything you need. It will be able to generate the scatter plot, generate the regression line, generate the R-squared value, and you will be able to copy this straight into your assignment, copy your graph straight into your assignment. Now the other thing I really strongly recommend that you do is that you put your headings in correctly right from the get-go. So this is going to be your first table. That pink one is not working. Table 1, and it is the effect of temperature on the change in pH, whatever it is. So you've got that right there, and that can also be copied straight into your report. You don't have to worry about trying to think of that later. So if you have not got continuous IV, continuous DV, one of them is discrete or both of them are discrete, you're going to have to set up your tables in Excel slightly differently. So I'm going to have a look at if you have got a number of things that you're comparing. So we're not heading towards the Ttest here. We're heading towards doing a column graph, and we are going to have standard error bars on the column graph. You still can put your raw data straight into Excel. Again, I recommend that you don't start right at the edges. Leave space so that you can add notes and add headings afterwards. But the thing that you are looking at first, so condition 1, condition 2, let's say we've got 3 things that we're comparing. Condition 3, whatever those are, put those headings up there, and then you're going to have a number of repeats. So put those down the side here. We'll go for 5. Okay, so these are your independent variables. These are the things that you're changing. You're changing them, each one, you're repeating it 5 times, and you're going to put your numbers in here. So say for instance you have chosen to do a student experiment on the effect of nutrient density on the number of yeast cells. Now the nutrient density is going to be continuous, but the number of yeast cells is discrete. So condition 1 might be 25% nutrient density, condition 2 50%, and condition 3 75% of the ideal level of nutrient broth. Now you're going to count 5 times for each of those 3 different things, And here you have 300 yeast cells per milliliter. In your second one you've got 330, in your third one maybe 325, 300 again there, and oh my goodness, suddenly you've got 500. Your yeast cells have become very virulent. And you'll have a list of numbers there and a list of numbers there as well. Again, your first thing is, as you're collecting the data, your first analysis is done in your spreadsheet. So again, I would recommend, if there's any number that looks like it's very different, highlight that cell so that you can remind yourself to look at it and maybe even make notes. Just make them on your Excel spreadsheet. Why is that one different? What could have possibly happened? Can you have any explanation? And do you need to do some research? For these data, you're going to be generating a mean and you're going to be generating a standard error. You're going to do that down this way. So you want the mean of those 5 results, these 5 results, these 5 results. So the place to put the mean is underneath, and then the standard error underneath that. Okay? Again, you want only numbers in these cells. No units. Put your units up there. You can see I've put the percentages up there. Because the data tool pack does not read anything but numbers. Alright, one more to go. If you are comparing two things, if for instance you are comparing two ecological sites that are spatially separated, you want to be aiming to do a t-test. So for that, you're going to set up your data in a similar way to the previous one. It's discrete data. You're normally counting organisms, but it doesn't really matter whether it's discrete or continuous. If you're using the t-test, you need to set it up like this. So you've only got 2 independent variables. So I'm going to call them site 1 and site 2. And I'm going to do an macro invertebrate count to see how many different species and different numbers of organisms are at each site. So I need to do a few repeats as usual. So I'm going to have 5 repeats, 1, 2, 3, 4, 5. In this case, I'm pretending that I'm going to be counting damselfly larvae, because I know that these are sensitive and they will give me an idea of the water quality in the area. So in site 1 I'm going to get 5 in my first count, in my second count 3, 1, 3 and 4, and then I do the same for site 2. You don't have to worry about anything else as long as you have set it up like that. So this is your independent variable here and here, and these are your dependent variables, your counts going down there. Once you've got it in this format, you'll be able to use the data analysis tool pack in Excel and generate the t-test and the p-values that you need. And that's it. Thank you for watching. I hope that was very helpful, and I look forward to doing a few more of these where we go into more detail, looking at exactly how you set up Excel and make Excel do everything you need it to do, and exactly how you interpret Excel's numbers and how you speak about them in a way that will allow you to get the highest possible grades that match the ISMG on the QCAA SE. After all, we are in QLD, so let's have some FUN while we're doing this. Bye!